Good morning. Hope everybody's doing well. I wanted to go through a couple more problems with you guys. Tomorrow we'll have another lesson posted along with another short assignment. It'll be what's called solving right triangles. So we'll go through, find all the sides and all the angles. It's not a whole lot different than what we're doing today. And then we'll mix some word problems in. I know you guys don't usually like word problems, but they're not that hard, I promise. So with these three problems, I want you guys to do the same thing that we've been doing the last few days. Go ahead, write them down, try to work them out, skip the video forward. If your answers match my answers, there's no reason to sit through and listen to the explanations, okay? So on the first problem, I'm going to have you guys find both the missing side lengths. So we're going to find the side AB and the side BC. I gave you guys a 31 degree angle here, and I gave you guys the length of this hypotenuse. Side AC is 10. The second problem, I want you guys to find the measure of angle X and the measure of angle Z. I've given you guys this right triangle, and I put the right angle right there, X, Y, Z, and the side lengths are 9, 12, 15. So I want you guys to go through and find the measure of both angles. And then the third one, kind of like yesterday where we had the challenging problem where you guys could think about it. If the sine of an angle X is 3/5, and you guys are going to notice that kind of works back to problem 2, it's going to say, what's the cosine of X? And we're going to talk about that a little bit. So go ahead, write those three down, work them out, and then skip forward and check your answers, okay? All right, let's go ahead and work through number 1. So when we're solving first thing we should always do, we're doing a trig assignment. So SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So we always have to have SOHCAHTOA for every single trig assignment we ever do. When you guys are solving for side lengths, that's when we're going to go through and we're going to have equations. So this first one, I'm going to put an X on AB, and I'm going to go ahead and put a Y there. So we'll solve for both of those. It doesn't matter what order we go in. Okay, so the side across from the right angle is the hypotenuse. The side across from our angle is opposite. The other side is going to be adjacent. So I'm going to talk about two different ways that we could go through and solve this. But so let's go ahead and let's solve for X first. So if I'm solving for X, my 31 degree angle is here. I'm working with the opposite side. And then the side length I know is the hypotenuse, which is 10. So O and H means I'm going to be using sine here. So I'm going to want the sine of 31 degrees. Remember, the sine of 31 degrees is the ratio of the opposite side over the hypotenuse. That's going to be equal to, and on the other side, we set the ratio up. So the opposite side is X. The hypotenuse is 10. Now, you guys remember there's actually a trick. When this number is down on the bottom, the trig function and the number just end up switching. So I know that this is, oh, actually, that's wrong. When the number's on the bottom, we know we just have to go through and multiply. Let's not worry about that trick. Let's go back and solve it. Sorry, guys, I was thinking about the variable being on the bottom. So to solve this equation, we're going to go through, we're dividing by 10 here. We need to do the inverse of division, which is multiplication. So if we multiply both sides by 10, I end up with X equals 10 times the sine of 31. And then we can just go punch that in our calculator. So we come here, I've got 10 times sine of 31, 5.15. So I come back here, I know this side X is equal to 5.15. Now, if we want to solve for Y, I'm not going to go through and put the 5.15 on this side. I'm going to kind of act like I don't even know it. But if I want to go back here and I want to solve for Y, now I'm working with the adjacent and the hypotenuse. So we're going to do the same thing we did before, but instead of using sine, I'm going to use cosine. So now we're going to say the cosine of 31 degrees equals Y over 10. You guys can use any variables you want. You guys could write BC, it doesn't matter. We're going to solve that the exact same way, guys. Multiply both sides by 10. That denominator goes away. Y is equal to 10 times the cosine of 31. And then we can go punch that into our calculator. 10 times cosine of 31 is 8.57. So Y equals 8.57. So So we've got that one, we got that one. So we solve for both missing side lengths. You guys could have gone through and used Pythagorean theorem to solve for that other side length if you wanted to. We'll talk about that when we get to the bottom one. Next one, they asked us to find angle measures. So you guys should remember that when they ask us to find angles, that's when we're going to use the inverse trig functions. Doesn't matter what order you guys go in here, but you guys might also remember that I told you guys before, when they give us all three side lengths, we have to choose which trig function we use, and it actually gets a little bit more confusing sometimes. So it's totally up to you guys, but let's start here with x. Okay, I know that this is the hypotenuse. I know that side doesn't change. I know compared to this side x, I know this is my opposite side and that's my adjacent. So to find the measure of this angle x, I can use any two side lengths I want in the inverse trig function. So if I wanted to use 9 and 12, I could. 9 and 12 would be opposite and adjacent, so I would just use the tangent. If I want to use 9 and 15, I could. 9 and 15, that's opposite and hypotenuse. I could just use the inverse sine. Same is true with 12 and 15. So I could just go through and use the inverse cosine. It doesn't matter which one you guys choose, okay? So sometimes I like to go through and almost act like one of these sides isn't here. I'm going to erase this in just a minute. But sometimes I would go through and even go, okay, that 12 doesn't exist. Don't even think about that. We've got 9 and 15. So let's go through and let's look at the inverse sine of 9 over 15 and see what we get. If you guys jump to your calculator here, got to go to functions, inverse sine, 9 divided by 15, 36.86. So I'm going to go ahead and call that 37 degrees. Okay, guys, we're going to round to the nearest whole degree. So the measure of angle x is equal to 37. We could use inverse trig to go through and find the other one. I'm going to do it just for fun. So if we go through and we look at angle z now I've got opposite, or I'm sorry, if you guys are looking at angle z, then the opposite and the adjacent are going to flip, right? So when we switch over to angle z, now that one's going to be in purple. Now the opposite is here, the adjacent's here. So again, I'm still pretending like that 12 is not there, and you could have used any number here, but then so I would have had adjacent hypotenuse. So I would know the inverse cosine of 9 over 15 would go ahead and give me the measure of angle z. And I can go back and punch that in. Inverse cosine. Oops, sorry, I got to clear that out. Inverse cosine, 9 divided by 15 is 53.13. We'll call that 53 degrees. You guys could always check because those two should sum to 90. 53 plus 37 is 90. And in all reality, to get the measure of angle z, usually, guys, I would have just gone through and done 90 minus 37. It was 53. So remember, when you guys are trying to solve for angles, you guys are going to use inverse. When you're trying to solve for side lengths, you're going to use regular trig. The third one. So they say the sine of x is 3 over 5. What is the cosine of x? This is a tricky problem to think about because they just told you something about the trig functions. What I want you guys to do if you run into something like this is think about what does it mean for the sine of x to be 3 over 5. If sine of x is 3 over 5, that means that the opposite over the hypotenuse is equal to 3 over 5. So that means I have a right triangle here, and it might not be drawn to scale. Don't worry about that. And if I have my angle x there, and it could be down in the other corner, I'm just going to put it here. The opposite side length is 3. The hypotenuse is 5. So I know that. They want me to know what's the cosine. Cosine is adjacent over hypotenuse. So I already know the hypotenuse is 5. All I need to do is I need to find out what that adjacent side length is. So if I put an x there, we can go through and we can solve for that, guys. That's a right triangle. If you guys have two sides of this, you could go through. I had somebody before use inverse trig, find an angle, and then go back and solve. That's a little bit too much work. You guys run into something like this. This is Pythagorean theorem. A squared, or leg squared, plus leg squared equals hypotenuse squared. So I know that x squared plus 3 squared equals 5 squared. That means x squared plus 9 is equal to 25. That means x squared is equal to 16. And x is equal to 4. So we can go through, guys, and we can solve for that missing side length. If they give you two sides of a right triangle, go through and get the other one. Use Pythagorean theorem. So once I know x is equal to 4, that goes right there. The cosine of x has to be 4 over 5. If I would have asked for the tangent, we could have done the same thing. It's 3 over 4. It would have been opposite over adjacent. As soon as they give you, you guys need to realize that the sine of an angle is the ratio of two side lengths. So they actually gave you those side lengths there. 3 more problems, just like a little warm-up that we would do in class. More practice. If you guys have got this stuff down, awesome. Tomorrow I'll post a video. I'll keep it pretty short with some word problems and solving right triangles, and then another short assignment. I'm going to stop calling our things meetings, and I'm just going to start calling them office hours. So I want you guys to remember, you don't have to come to when I do the Schoology conferences. I'm posting these videos for your guys' lessons so you guys can go through and pause and kind of work through them on your own. The Schoology conferences are for you guys to ask any questions. The one thing I will start doing is I'll start waiting around a little bit longer. Yesterday, we started the conference at a certain time. And only one person showed up. So since only one person showed up, I stuck around for about 5 or 10 minutes, and then I went ahead and left. I got a couple of remind messages later where kids were asking where I was. So we'll call it an office hour. I'll try to stay in the conference for the whole hour. If I walk away from the computer, sorry, I got 3 kids. One of them just tried to walk into the bedroom. So I will post another video tomorrow. I will be available online today starting at about 11, okay? Talk to you guys later. Hope everybody's doing well.